Hi there. So let's have a conversation about bytes and gigabytes, and maybe we can start to cope with that question about the Harry Potter novel and how it is we're going to fit how many sets of seven Harry Potter novels onto a 7 gigabyte thumb drive. Well, let's talk about the terms in play and how they work together. First of all, what's a byte? Well, a byte in computer terms is the most basic unit of data. It's a chunk of data. It's not the smallest. The smallest, as you already learned, is a bit. It is really too small to use on its own. It's not even a letter like a T. It's kind of a freckle on the T. It's a part of a T. So you're not even dealing with this whole character here. You're dealing with one little piece of it. Well, when you put 8 of them together, you get something called a byte. Now, a byte is about the equivalent of one character. Let's say the letter T on a text document. Now, what if we have a bunch of them? Well, let's try to come up with a practical way of looking at this so you can understand this notion of a byte. For example, bytes in real life. If it's a single character like a letter, you can think about a very well-known speech, Lincoln's Gettysburg Address. That is 1,397 characters, or about 1,400 bytes. Now, next thing we got to understand is the thousands principle. We already do this in our regular common language when we talk about money or we talk about other things. If you have a bunch of dollars, you talk about your bankroll, and that's great. When you put 1,000 of them together, you don't say, I have a bunch of ones that are, you don't say it in any funny way. You just say, I have $1,000. So 1,000 ones gets you to 1,000. Now, if you have 1,000 thousands, then that's going to get you to 1,000,000. If you have 1,000 millions, that's going to get you to 1,000,000,000. And as you can see, that we use words, thousand, million, billion, just to represent those higher numbers. Computers does the same. We do the same thing. The only thing is, our magic number in computers is 1,024. We jump at roughly 1,000 intervals, but the magic number for us is 1,024. Why? That's a lesson for another time. Now, remember the magic number is 1,024 to go from kilo to mega, to go between levels. So let's get to the names. Now that you know about the thousands and now that you know what bytes are, the last principle to remember is that memory is always growing. Our ability to store things, we keep doing it better and better every year. And the media we store things on gets smaller. My first hard drive was a 20 megabyte hard drive. It stuck to the bottom of my Mac Plus. It was about a foot square, it was about 3 inches tall, and it weighed about 12 pounds. Now I carry a 5 gig or an 8 gigabyte thumb drive in my pocket. Now Moore talked about this. If you remember Moore's law and the number of integrated circuits that seems to double every couple of years. So Moore's law is talking about that phenomenon. So when you talk about bytes, the numbers get too big. When you talk about these bigger numbers, you can't just express them in numbers of bytes. So they came up with a naming system. The first name they figured out was something called kilobytes. So you take our friend the Gettysburg Address. It's about 1,400 characters, roughly 1.4 or 1.5 kilobytes. Still a very, very small document. Now, when you put 1,024, roughly 1,000 of those kilobytes together, you get something called a megabyte. So 1,024 times 1,024 bytes is a megabyte. That's 1,048,576 bytes. So 1 megabyte, roughly the size of an old 3.5 inch floppy disk, that's something that's a million bytes. Now, when you get to gigabytes, you've jumped another 1,000 up from the megabytes. So it's the same process, 1,024 times 1,024 times 1,024. Your math teacher would say it's 1,024 cubed. In other words, it's 1,073,741,824 bytes. Or in terms of our Gettysburg's addresses, it's 766,958 copies of the Gettysburg Address. I don't think you'd ever need that. But that's one way to think of it. We've gone from being able to store one little tiny piece of data to, on a very small thumb drive that you can't even buy anymore, you could store over 750,000 copies. Now, my average, below average thumb drive, for example, great example of this. It's hard to even find the 8 gigabyte thumb drives unless you go to a Five Below or a dollar store. And those 8 gigabyte thumb drives themselves have 8,589,934,592 bytes. That's an enormous amount of storage capacity. So, let's get over to Harry Potter. The thing about Harry Potter is they talked about there's 7 novels with about 7 million characters total. Here's the number to remember. You have 7 million characters in one set. 7 million characters in one set. I'm going to take you through the problem, but I'm not going to do it for you. Stay with me. All you got to do is a simple division problem. Here's what you know. There's 7 million characters that make up 7 million bytes. So it's about 7 million bytes a set. There's 7 gigabytes is how many millions of bytes, right? Now, you divide the billion bytes by the million bytes, and you're going to come up with a very round estimated number of the number of sets of Harry Potter novels that you could fit inside of a 7 gigabyte thumb drive.